Okay, so different ways they can ask this. They can, for instance, give you a sequence of rectangles and ask you to determine the area of the 19th one. So over here, they could tell you that this side increases with 2 every time, while this side increases with 1 centimeter each time. So even if they're asked to get the fourth, I can just immediately get the fourth in the pattern by just saying, okay, if this increases by 1, the top one would be 5 centimeters, and the side, if it increases by 2, would now be 7 centimeters. Okay, so I can get the area, since they wanted pattern area, the area of each of them. So I can just say, okay, that's length times breadth. This would be just 2. This one would be 9. This one would be 20. The next one would be 35. And I can go on like that and actually determine all of them if I wanted to. The next thing I can do is I can look at what my first difference is, which is not constant, and I can look at my second difference to see if it is in fact constant. So this would be 4, 4, we can see our second difference is constant. So this is 2a, this is 3a plus b, and this is a plus b plus c. Okay, so we have a pattern, and we can say a would be equal to 2, just solving this. 3 times 2 plus b would be equal to 7 using that. And we can say that b would be equal to 1. And we can solve for c by saying a plus b plus c is equal to 2. So c must be equal to negative 1. And we can get a general formula and say it's 2n squared plus n minus 1. We can test if it gives us our answers. So we can plug in 3, for instance, and say, okay, that's 18 plus 3 minus 1, that is 20, so it works out for term 3. Then we can try and calculate term 19, and we can say that would be 740, okay, and centimeters squared. So this is a different way of doing it. We could give you any shape with just sides, or one side changing, or a radius. So you need to know your basic shapes like triangle, half base times height. It's the area. You need to be able to do perimeter. Just add your 3 sides, or twice length times plus twice breadth, or all those types of things, because you can use them in patterns like this. Okay, then for instance, I could have 3 right-hand triangles like this, and a question could be determine the length of the hypotenuse of the 22nd triangle. So this length increases by 2 each time, so I know the next one would be 7. This length increases by 1 each time, so I know the next length would be 4. And I know what the hypotenuse would be for each of those because I can calculate it. But I'm not going to deal with square roots, so let's do hypotenuse squared first. From there we can always determine the hypotenuse. So hypotenuse squared, I can get a pattern for. For my first triangle, it's just going to be 1 squared plus 1 squared. Okay. For my next triangle, it's going to be 3 squared plus 2 squared. Okay, so I'm just using one side squared plus the other side squared. Okay, so my hypotenuse for the third one would just be 5 squared plus 3 squared. For the fourth triangle, it would just be 7 squared plus 4 squared. And I can go on like that and say, okay, the next one would be 9 squared plus 5 squared. So now I have my pattern. Okay, we want the 22nd. We're not going to list all the way to 22. We're just going to say we're going to look at our first difference, and we can get a pattern there. Okay, we can see it's not constant at the moment, so it's not a constant first difference, but it may be a constant second difference, which is in fact the case. Okay, So now we've got a constant second difference, we have a quadratic number pattern, and we can use this. So we can say a is equal to 5, 15 plus b is equal to 11, just substituting a into that thing, and therefore b is equal to -4. Using that, 5 plus -4 is 1, so c must be equal to 1. I'm just solving for it very quickly. Normal steps. Then Tn would then be equal to 5n squared minus 4n plus 1. We can check if it works out. Let's test it with the 1, 2, 3, 4, 5, the fifth one. So if we had 5 times 5 squared minus 5 times 4 plus 1, that is in fact 106. So it does work out. We've checked it. Okay, so if we want the area, oh sorry, not the hypotenuse, and this is going to give me my hypotenuse squared though, of the 22nd triangle. I'll just substitute that in and get that it is equal to 2333. Okay, this is the hypotenuse squared. It's 2333. So my hypotenuse would just be the square root of that number. So the square root of that number is going to be 48.30 dot, 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 dot. Okay, 30 rounded, so centimeters. Okay, so then I've solved for the hypotenuse. So it can be asked in a way like this as well. Okay, here are these two questions. Next, I'll quickly do one where it is just a quick question of if they go and change things so that we have a pattern 1, 2, x, 3, y, and they tell us, let me use different values perhaps. Let me use 1, 7, x, 19, y, and they tell us this is quadratic. Okay, so quadratic pattern like this. If we were to fill this out, okay, even without solving for anything, very important, the first difference is always this term minus that term, so it's x minus 7. Okay, don't make a sign error or something. This is 19 minus x. This is y minus 19. If I check the difference there, remember it's always this side minus that side, so it's going to be x minus 7 minus 6, so in other words, x minus 13. Okay, this would be 19 minus x minus the entire thing there, so it's going to be 19 minus 2x plus 7, which is going to be 26 minus 2x. Okay, be very careful when doing those types of things. For the next difference between those two, always this side minus that side, so it would be y minus 19 minus 19 minus x. I'm minusing the entire thing, put it in brackets. It's going to be y minus 19 minus 19 plus x. So in this case, it would be something like this, where it is y plus x, and then it would be minus 38. Okay. Okay, and then I could actually go and solve for x and y by saying these things are equal because it's quadratic, so my second difference is equal. So x minus 13 must equal 26 minus 2x. So 3x must be equal to 13. Okay, and then we get x is 13 over 3. It is possible to have rational numbers inside number patterns like this, fractions. So don't get scared of that. Okay, after we solved for x, we can say, okay, so our constant difference must then be equal to x minus 13, so 13 over 3 minus 13 is our constant difference. So let me just put them all over 3 rather, and say this is then equal to 13 minus 39 over 3, negative 26 over 3. So you can leave this as it is. Okay, negative 26 over 3 would be our constant difference, or our constant second difference. And then what we get is that we can solve for y. Negative 26 over 3 must be equal to y plus x is equal to 13 over 3 minus 38. So I can just do 38 minus 26 over 3 minus 13 over 3 is equal to y. Okay, so this would be 38 minus 39 over 3 is y, and then I've solved for my y value as 75 over 3. Okay, which is just 25. So I can solve for something. Very important that you always do this minus that for the second difference. Always right minus left. Okay. Then the last little thing I want to mention is on something with, for instance, like similar to that triangle question, but let's say instead of being triangles, it was something where, like they asked, for instance, amount of dots, they could ask the amount of sticks to make up a triangle. So we could say, okay, we're doing this with toothpicks and we're building triangles like this. Okay, and this is the first one in my pattern, this is the second one in my pattern, third one in my pattern looks something like this, where there's an extra base added, so it's like this. And then obviously you can go and draw the fourth one if you want. And they ask you, instead of anything else, get the amount of sticks in this to create these triangles, and you can count them. It would be 3. You could get 9 for the next one. You can count the next one would be 18. If you draw the last, like fourth one, you'd get 30. Okay, and you might have to actually draw it yourself just to get the pattern there. And then you can see they might ask you to predict the 90th triangles amount, or the 90th iterations amount of sticks. So we might get this is 6, this is the 9, this should then be equal to 12. So you can see we have a constant second difference, and from there we can get a pattern as well. So just be aware, they might ask you to do different things, like count the amount of sticks, count the amount of triangles, count the amount of dots. So there's many different ways the same aspect can be done. We just need to physically count them. Okay, so I'm not going to solve this entire one. You have the idea. Go and practice those questions and look in your textbook for more that are similar.